An often overlooked behavior is the simple ability of a creature to right itself. Today, we'll see how several different insects accomplish this task in the lab. First, the insects had to be calmed down in order to be placed on their backs, which was accomplished by chilling them in the freezer for a few seconds. Once the insects warmed up, they began to work to right themselves. Here, we have an assassin bug. Due to its wide abdomen, its legs are not long enough to make sufficient contact with the ground to generate enough force to roll over. Watch as it uses its wings instead to flip forward to right itself. This stink bug, on the other hand, does have long enough legs to utilize them in righting itself. See how it uses both hind legs to push itself up until the weight of its own body causes it to fall forward. Both of these true bugs direct their bodies in the same way, but with different appendages. This ground beetle also uses its hind legs. However, it uses one hind leg to provide a downward force against the ground, and the other to provide a levitational driving force to roll along its longitudinal axis to right itself. Let's watch it in slow motion so we can see this better. The Japanese beetle has body proportions similar to the stink bug, so it too uses its hind legs to push itself up and fall forward in order to right itself. As you can see, body shape and size play an important role in how an insect rights itself. Now let's take a look at another type of insect, the codling moth. The moth is completely unable to touch the ground with any of its legs, so it must rely solely on its wings to turn back over. The moth's powerful wings are fast, so let's slow that down to see them in action. Unlike the previous insects, the moth flips backwards rather than forwards. An insect with one of the more unusual righting behaviors is the click beetle. The beetle is hinged at its first and second thoracic segments, with a spine protruding from the first that fits into the notch of the second. The beetle flexes dorsally, sliding the spine into the notch. A thoracic longitudinal muscle stores elastic energy that is released abruptly when the spine slides out of the notch. This release of energy causes the beetle to jump into the air. However, the beetle only has a 50% chance of landing on its feet, so sometimes it takes multiple jumps before it rights itself. An insect on its back is vulnerable to predators, so it is a matter of survival to turn back over as quickly as possible. Righting behavior may seem simple and basic, but as you've seen today, it is complex and can be accomplished in many different ways.